Hey kids, Miss Butcher here, and welcome to Imaginary and Complex Numbers. So when we solve quadratic equations by factoring or completing the square, like we have been, we are finding where a parabola crosses the x-axis. However, sometimes our parabolas don't cross the x-axis. So up until now, when we solve these, we've been saying no solution. But they do have solutions, they're just imaginary. For example, this one, suppose the equation for it was y equals x minus 6 all squared plus 4. And if we wanted to solve, we would subtract, we would set it equal to 0, right? 0 equals x minus 6 all squared plus 4. And then we would take away 4 from both sides. And now we have negative 4 equals x minus 6 all squared. And to solve this, you would then take the square root of both sides, but that's where you would get stuck, because you would have plus or minus the square root of a negative number equals x minus 6, and you would just stop, and you would say, well, I can't take the square root of a negative number. But you actually can. You just have what we call an imaginary result. So from now on, whenever you're trying to take the square root of a negative number, keep in mind the square root of negative 1 equals I, and I is for imaginary. So if you learn anything at all today, that's what you're going to learn. The square root of negative 1 equals I. And now conversely, if I were to square I and square the square root of negative 1, I'd get negative 1. So I squared equals negative 1. These are the two things that you really need to learn and know about complex and imaginary numbers. Alright, so let's look at how this can work. If we have I squared, I just told you that equals negative 1. If I had I cubed, just break it into I squared times I. And we know I squared is negative 1, so negative 1 times I would be negative I. If we have I to the fourth, break that into I squared times I squared, or I squared squared. Either way, we have negative 1 times negative 1, which equals 1. We could do I to the 10th. That would be I squared to the 5th power, which would be negative 1 to the 5th power. And anytime we raise negative 1 to an odd power, we get negative 1. So if I did something crazy like I to the 43rd, I could turn that into I squared to the 21st power, which would give me I to the 42nd. So we'd need another I, so put times I squared to the 21st, that's like negative 1 to the 21st times I. 21 is odd, so that's going to be negative 1 times I, which is negative I. And you can do this for any power you wanted to. Alright, so here's some quick example problems. If I asked you for the square root of x, you would break that up into the square root of negative 1 times x. We know the square root of negative 1 is I, so this would be I root x. If I had the square root of negative 7, well, same thing. I know the square root of negative 7 is the same thing as square root of negative 1 times 7, so that would be I times the square root of 7, or I root 7. If I wanted the square root of negative 9, that's the same thing as the square root of negative 1 times 9, which is I times the square root of 9, but we know the square root of 9, so that's I times 3, and we say 3I. Square root of negative 12, basically whenever you see a negative in here, I'm going to stop saying square root of negative 1, I'm just going to pull it out and turn it into the letter I. You see that? So I have I times, and then the square root of 12, make sure you reduce your radical, simplify your radical, and that would be 2 root 3. So we would say 2I root 3. Negative square root of negative 36. A lot of people think, oh, these negatives cancel out, but they do not. One is on the outside, one is on the inside. The one on the inside becomes I, so we've got negative I times the square root of 36, which we all know is 6, so this becomes negative 6I. And here we've got negative square root of negative 28, so same thing. The negatives do not cancel out. This one becomes the letter I, so we have negative I times the square root of 28. And then we can break down the square root of 28 because that's 4 times 7. So that actually becomes negative 2i on the outside and then square root of 7. So they can get pretty nasty looking, but always just remember, if you see a negative under the radical sign, pull it out and turn it into the letter I. Okay, so that was imaginary numbers. Now we're going to talk about complex numbers. Complex numbers are numbers that include a real part and an imaginary part. And they are written in the form a plus bi, where a is the real part and bi is the imaginary part. Also, please keep in mind that the real part always comes first. That's important. Okay, here's some operations examples with with complex numbers. See this first one? Super easy. I shouldn't even waste my time going through it because there's a plus here. And all you have to do is combine like terms. But every single time I put this on a test, somebody foils this. And you know better than that. So we're just going to combine like terms. We're going to do the real part first. Negative 4 and negative 4 makes negative 8. And then we're going to add the imaginary parts. I plus I is 2i. It's that easy. Alright, this next one, same setup. We've got subtraction. We've always got people who forget to distribute their minus sign. We're looking at 5 minus 3i minus negative is plus 1 and then minus I. So we combine our reals first. 5 plus 1 is 6. And then we combine our imaginaries. Negative 3i minus I is negative 4i. Down here we have multiplication. Negative I times 5 plus 2i. So of course you're going to distribute. We're going to get negative 5i. And then we're going to get minus 2i squared. But don't leave it as I squared. Every time you see I squared, you have to think, I know what I squared is. I squared is negative 1. So cross it out and write negative 1. So now we have negative 5i, and then negative 2 times negative 1 is plus 2. And of course, since we always write this real plus imaginary, you're actually going to say 2 minus 5i as your final answer. So watch out for that. First, you have to know the I squared, then you also have to remember the real plus imaginary. Alright, and then this last one you actually will FOIL because there's an implied multiplication sign right there in between them. So we go first, negative 7 times 3 is negative 21, and outer, negative 7 times 2i is minus 14i, and inner, negative I times 3 is minus 3i, and last, negative I times positive 2i would be minus 2i squared. And so, remember, take your I squared, cross it out, and write negative 1. So now I have negative 21. I'll go ahead and combine these, minus 17i. And then negative 2 times negative 1 is plus 2. So my real part is negative 19, and my imaginary part is minus 17i. When we want to divide complex numbers, we use the same process that we used when we were doing rationalizing denominators with complex denominators. We're going to multiply the top and the bottom by the conjugate of the bottom. So in this case, the bottom's conjugate would be 1 plus 4i. And I'm going to do that to the top and the bottom. And now we have to FOIL the top and the bottom. So we've got 7 plus 28i, plus 5i, plus 20i squared, all over. And then I have 1 plus 4i, minus 4i, and minus 16i squared. So then we clean it up a little bit. I'm just going to take this plus 20i squared, cross it out, and write minus 20, because I know the I squared is negative 1. And I'm going to take this minus 16i squared, and I'm going to cross it out and write plus 16, because minus minus becomes plus. So I have 7 minus 20, which is negative 13. And then I have 28i and 5i, which is 33i. And then on the bottom, these cancel out, and I have 1 plus 16 is 17. So I'm going to put each of these over 17. And the reason I'm doing that is so that I can follow the rule that says real plus imaginary. So I have negative 13/17 plus 33 over 17i. Alright kids, pause for a quick second. I need to give you a code word. This is good for both Miss Irwin's class and my class, but do not go telling anybody what the code word is. If either she or I hears this word coming out of your mouth before class or whenever, you will not get whatever it is you're going to get for knowing this code word. Alright, so your code word is something that is imaginary. Your code word is unicorn. And I was going to put a picture of a beautiful unicorn on here, but when I was Googling unicorn, this came up and I just couldn't resist sharing this with y'all. Alright, now I'm going to tell you that we can actually graph complex numbers. Only we don't do it on the XY coordinate plane. We are going to do it on a real imaginary coordinate plane. So what you would do is, suppose you had the complex number 4 plus 3i. Then you would go 4 units on the real, and then you would go 3 units on the imaginary, and put a point there. So there's 4 plus 3i right there. Or say we wanted to graph negative 2 minus 5i. Then we'd go 2 on the real, and down 5 on the imaginary, put our point down there. That would be negative 2 minus 5i. Or let's say we wanted to just graph like, I don't know, 5i. Then you would go 0 in the real direction, and then you would go up 1, 2, 3, 4, 5 in the imaginary direction. That would be 5i right there. Now the next thing you need to know is about the absolute value of complex numbers. And that is, the absolute value is the distance from that point to the origin. So from here to here, or from here to here, or from here to here. And the way you would do that is you would just create a right triangle. You see that right triangle? That's got a length of 4, and that's got a length of 3. So you would just use the Pythagorean theorem to find the length of that, and that's the absolute value of your complex number. So the way to find the absolute value of a complex number is to just take the square root of a squared plus b squared, where a is from a plus and then bi. So what you're going to do, if I said the absolute value of 2 plus 3i, is you would go square root of 2 squared plus 3 squared. You see how the I does not show up anywhere in that absolute value thing. It's gone. We're just finding a numeric value. We don't need the I. So we're doing the square root of 4 plus 9, which is the square root of 13. That's the absolute value of your complex number. And that's the end of our video for the day. Thanks guys. Have a good night and keep it real.